Well, hello everyone, and welcome to a new video. In this video, I'm going to be talking about linked list. Now, linked list as a concept is quite complicated, not quite, a little bit complicated, if you will. And in this video, I am going to assume that you only have a knowledge about pointers, and we just need to know and learn about linked lists and how do they work and how do they function. Now, in reality, linked lists is a lot more complicated than what I'm going to be showing you today, but you should just know that I'm trying to make it as simple as possible. Now, what I'm going to be doing, I'm going to be using the Paint software here and Visual Studio, which I already created the project, and I'm just going to try to explain here really fast. So what is a linked list? A linked list is basically a group of nodes, and those nodes are connected together. Now, you should know that we have a lot of different types of linked lists, but today we're just going to talk about the simplest one, which is what we call a single linked list. Now, each node by itself, it's an object, which mainly contains consists of two parts. This is where you put the data. This is where you have a pointer to the next node. So here we go. This is a node. This is data 2. This is pointer 2. This is node 3, data 3, and pointer 3. Now, remember, this is node 1. This is node 2. This is node 3. And the pointer here, the whole point here is that this pointer here is holding the address of the second node. And the pointer here is holding the address of the third node. And this one, since it's at the end, is going to be pointing to a null PTR. And also, I will have a special pointer. We call it the head. And the head is just going to be pointing to the first node. So this is what a linked list look like. Now, let's just put some assumptions here before I start showing you the project. We can look and treat the whole linked list as one object. So for example, I can look and treat the whole list as one object. That's one option. Or I can look at the whole thing as multiple objects. So this is going to be object number 1, this is going to be object number 2, this is object number 3, and I just make sure that they're connected properly. So in this example, or in this video, I am going to treat each node by itself as an object. So I don't have one object that contains the whole list. So this is my first assumption. My second assumption here is, as I said before, I am just going to consider a single linked list. So I can only move in one direction, which is from the head all the way to the end of it, which is what we call the tail usually. I cannot go backward. That's a second assumption, which is, again, a really big deal when it comes to the implementation. So these are my assumptions now. What I'm going to be doing here, I'm going to create a class. And in this class, I'm going to create nodes. And then in this nodes, I'm going to create a group of methods. But the most important method that I'm going to have in this class is, how do you add an element after a node? So for example, if I want to insert a new node here, for example, let's go ahead and do that. Imagine that I'm going to create a new node. I'm going to call it node A. So when you create a node A at the beginning, let's call this one data A, and this is going to be pointer A. And we're going to call this one, for example, node A. And imagine I want to insert this node after the first node. So what I'm going to be doing here, I'm just going to have to change the pointer. Assign the pointer of PA to be pointing here. So that will be my first step. Now you can see here that I have two nodes are pointing to node 2. Right after that, I need to change the pointer 1, and instead of pointing to 2, it's supposed to be pointing to an A. And as a result, this connection here will not exist anymore. And now you can see here, I was able to insert a new node, which is NA here, after N1. That's one of the main operations that we're going to do. Also, I'm going to show you, like after we complete a couple of assignment and insertion, adding nodes, I'm going to show you how do we print the data elements for these nodes. Now, this video is going to be containing two parts. The first part where we're going to discuss how do we add a node after a given node, and then we're going to talk about how do I add a node before the given node. For example, if I want to insert a node, let's say data B and then pointer B. Let's make it lowercase, and then pointer B. Now, if I want to insert a node, giving this node here, I want to insert a node before it. Now, that's going to be a totally different story. It's going to be a little bit more complicated than inserting a node after, because we said we can move in one direction. We cannot move backward. So because we cannot move backward, this is going to be a little bit more complicated. Of course, as I said, this is going to be part 2 of this video. So let's focus on how do we insert a node at after a given node. Let me jump into the Visual Studio. Now, in this area here, I created a project. I created a class. I call it node integer. Integer basically indication that the data is going to be a type of integer. Now, if you go here to the private section of this class, I have the data element, which is integer. I called it X. You can call it anything you want, of course. And then we got here a pointer. Now, what is the data type of that pointer? It's basically the same class. And that's what I was talking about. I have a pointer. Let's go here. I have a pointer here, for example, P1, and P1 is pointing to a node. So this is what I have here. So I have a pointer, and this pointer is pointing, I call it next. So far, I have no values assigned to next. Just keep it that way. Now, let's go and talk about the methods inside this node integer. First of all, I have the default constructor. I am basically assigning X to 0, and I'm assigning next to null pointer. I have no data, so those are the default values going to be assigned to. Now, this is the argument constructor. I am going to pass an integer as an argument here, and I'm going to assign it to X, and most importantly, next is still going to be pointing to null pointer. This is going to be updated, of course, later when we're going to start connecting those nodes together. This function here, getX, will return X. This is going to return next, so whatever the node you're pointing at is going to be returned. And then we have set X. This is where you can change X. So what we're going to do here, we're going to change next to be whatever the pointer that's going to be passed here. I'm going to show you graphically how is that going to be done. And this is the part that I was talking about when you want to insert after. So you're going to have a current node, and you're going to have the node that you want to insert after it. So this is the new node that you're going to be inserting after it. So the first thing we're going to do here, we're going to change, look at this, this is very important. For this new node, we're going to change the next of it to be whatever the current node is pointing at. And that's basically what I mean. Look at this line here, and I'm just going to show you what I did here. In this area, the part where I took the PA of this node and I made it pointing to this node. Now remember, this node N2 was pointing that by P1. So whatever P1 was pointing at, I will make NA pointing at. And that's what happened here. So look at this. Set the next for the new point to whatever this next is. Now remember this, we're talking about the current node that we're talking about, that we're trying to insert after. Right after that, we're going to have to come to the current node and change its next. Because previously, and let me show you that, previously, this node 1, for example, was pointing to this one. Now I want it to be pointing to this one. So if you go back here, you'll see that this set next is going to equal the new node. And that's how simple it is. Now, this part is where we insert add before. Look at this. This is add after. This is add before. Look at add before. It's a little bit more complicated, a little bit longer. And most importantly, add before is not part of the class. And we're going to talk about that later. But for now, let's just skip that part and let's just go and look at this main function. What do I have here? I'm going to show you what I'm doing here. If I go to, let me copy that. And I'm going to go to the paint here. And let me just paste those statements here. Let me increase the font size. Okay, I still have some space here. Okay, so here we go. I created a new head. Okay, let's go ahead and show you that. At the beginning, let's go here, for example, this area. I got a head. Now head has no values. And then after that, I created a new node. This node, look at it, has the value of 10. So I'm going to have a node here. We'll have the value of 10. And the P, or the next, let's call it next because I'll just go with N, is pointing to null PTR. Why is it null PTR? Because again, I'm calling the argument constructor, and we decided that the data is going to be set to whatever we're going to pass, and the next is going to be set to null point. And look at this. I said head equal node 1. So basically, immediately, I'm changing head to be pointing to this node. Now let's get this. Here I'm creating a new node. I'm going to call it node 2. Now remember here, this is node 1. Let's create node 2. I'm going to create node 2, for example, in this area. In node 2, just like I did before, I'm going to have 20 here, and this is going to be next, and next is going to be null PTR. Now look what I just did here. I said node 1 add after. So I'm going to add node 2 after node 1. And based on the definition that we had before, let's just go back here and show you what I'm going to do here. We said there are 2 steps. The first thing we said, we're going to make this null to be pointing to whatever node 1 was pointing at. So, for example, node 1 was pointing, the next of node 1 was null point PTR. So I'm going to change this end to be null PTR, which basically I'm not doing anything because it's already been using to point to null PTR. But most importantly, I'm going to make the next of null pointer to this one. Now let me just simplify this by cutting this part. And let me just take it and put it in this area here. Okay, what do we have? We have this part. Now, what are we doing here? We're creating a new node. What I'm going to do, I'm going to create the node. Let's just put it here, for example. This is node 3. Node 3 will have the value of 30. Look what I'm doing here. I said node 1 add after node 3. Now, remember here, this wording may not be clear, but what I mean by node 1 add after basically means add node 3 after node 1. Now, this is the case where we have to pay attention to. So I'm supposed to put, let's go here and put n, and n here equal null PTR. Now what I'm supposed to do here, let me take this from here and put it down here. What I'm supposed to do here, there are 2 steps as we said before. The first thing, I'm going to make this this next to be pointing to whatever the next of 1 is pointing at. And in this case, since node 1 is pointing to this one, I'm going to make oh, sorry, I'm not supposed to take that one. I'm supposed to take this one away. Instead of pointing to null, this one here is going to be pointing to node 2. And then after that, we said this one, node 1, is not supposed to be pointing to node 2 anymore. It's supposed to be pointing to the new node because we're starting to insert it after. So here we go. And that's basically what happened here. I added node 3 after node 1. Now node 4, let's just do that again. What do we have? We have the value of 40. We have n again. N is going to be by default null PTR. Now, what am I supposed to do? Oh, null 3 add after. So let me cut this. And I'm going to put it in this area here. Now remember what's going to happen. First of all, we said whatever node 3 is pointing at, I need to make node 4 pointing at. So basically here, instead of having a PTR in this area here, it's basically going to be pointing to this node. Now I have 3 and 4 pointing to the same node here, which is 20. Now after that, we said second step is to make the node 3, instead of pointing to that old one, is going to be pointing to the new one we just added, which basically is node 4. So here we go. This is my linked list. I'm going to start with 10, I move to 30, and I move to 40, and then I go back to 20, and then I am done. Let's go back to the code and see how do we print the data. What do I do here? I basically create a temporary pointer for a node and I assign it to head. So temp is going to equal head. Why do I do that? Because I'm going to update temp a lot. I don't want to update head. Heads need not to be changed. It's supposed to be pointing to the first node. But I'm going to use temp here because I'm going to change it a lot. So that's my first step. Now I'm saying here, as long as the next of that temp doesn't equal null, show me the data and show me an arrow after that. And then after that, move to the next node. Look at this. Temp is going to be updated to equal whatever the next one is. So if I want to take this piece of code and put it in graphically to present what's going on here, let me just copy this. And I'm going to go here and let me take this part away. Take that away. And let me just come here and put that piece of code in this area here. Let me increase the font size. It's going to be 20. Oops, that's too much, but it's okay. Okay, so here's what I did. I came here and I said, now here, temp is going to be pointing at the first node. And I'm going to say get next. Get next basically means I'm trying to get the next node, which is this one here. No, actually not this one. Temp by itself is pointing here, and the next of it's here. I said get next, so I'm talking about this one here. If this n here doesn't equal null pointer, okay, which doesn't equal null pointer in this case, I want you to show me the data. So 10 is going to be printed, as you can see here, and then followed with the arrow. After that, look what I'm going to do. I'm going to say temp. This temp is going to be updated to equal whatever whatever this n here is pointing at. Now this n is pointing to this one. So what's going to happen after this line here? Temp is not going to be pointing to node 1 anymore because I updated it to equal whatever it was before. So temp at the beginning was this one. Get next, which basically this is the next of it. I want this now to be assigned to temp. So after this line, temp basically will no longer pointing here. Temp is going to be pointing here. And same thing here. We look at this n here. As long as it's not a null pointer, show me the value. So it's going to show me 30, and then it's going to show me the arrow, and then temp is going to be updated. And when it's going to be updated, it's going to be updated to whatever this n is pointing at. And in this case, temp is going to actually start pointing at what? The third one, which is 40. So temp is going to be pointing here. Now we go back here and we said the next of this node, which doesn't equal null still. So it's going to show me, I'm going to go down here, 40, and then the arrow. And then after that, it's going to be updated. So instead of be pointing to this here, it's going to be pointing to whatever the 40 was pointing at. And I can take it away from here and move here. So temp now is pointing here. Now here's the problem when you get to this point. Temp of n is null pointer. So this condition is not true anymore. This is false. So the compiler will just jump from here. It's not going to print anything. I just got 10, 30, and 40, but I didn't get to a chance to print the 20. Which obviously, I did that for a purpose. So now temp is pointing to the last node, as you can see here. And the next of the last node is basically null pointer. So this condition here is going to be false. So your while loop is going to be terminated, and you're going to skip it. All I did here is show me the data of temp, which is basically 20, and it's going to be printed here. And that will be it to print those nodes. Now, let me just go to this part and let me run it. Remember here, we're supposed to see 10, 30, 40, and 20. That's the order I chose, and here it is 10, 30, 40, and 20. Of course, you can change it to be whatever you want. You can add any node you want at any place. But remember here, we're just dealing with add after. The next part of this video is where we're going to be talking about adding before function here. So I do have this piece of code here, and I'm just going to explain the effect of running those codes, and then I'm going to go back and try to explain what's going on inside this function, even though it looks a little bit complicated, but it's okay. Now, this is the part that you need to understand. there are multiple ways to implement linked lists, and some methods may be more efficient than others, but since we're beginners here, we don't know that much, so I think this should be work just fine. Let's go ahead and the whole point again of me creating this video is to give you an idea about how does linked list works, and then if you take this understanding and you apply it anywhere else, it should work. Of course, you just need to know that the way that different programmers interpret linked list and implementation may vary from one source to the other. So here we go. I'm just going to go and use the same example. This time I'm going to change something a little bit. So I created a head here. So let's start with that. We got the head, and then we have the new node, and the node that we created is 10. And we got the next. So next at the beginning is pointing to nothing, and then the head is going to be pointing here. The next node that we're going to add, which is node 2, we added it after node 1. So basically node 2 is going to be inserted in this area. So there's going to be 20, and this is going to be n, and n again is pointing to nothing. Now this is the part where I create a new node, node 3, and this is the most important part, add before. What do I have here? I have the head, the address of the head. I'm going to explain why the address later. And I have the node, which I call the target node. So this is going to be the target node, and this is going to be the new node that I'm trying to add. Remember here, the idea here is you cannot go backward. So what we're going to do here, we're going to look for node 1, and then after node 1, we're going to try to insert, we go to the node before node 1, and we try to insert after it. So the idea here, let me just tell you, for example, if I want to insert before node 20, if that's the case, what I'm going to be doing, I'm going to be looking for this node 20. And once I found the node 20, I'm going to use the node before it. And I'm going to use this node before it to insert after it. That's the only way you can do it using the structure that I showed you. So the idea here for insert or to add before is to look for the node that you want to insert before, and then you go backward one step, which basically I'm going to show you how is that possible, and then you just perform a very simple insert after. Now let's go ahead and see how is that possible. Now we have two cases. If it happened that the node that you're trying to insert before is the first node, then that's going to be a little bit different because we don't have a node before it. So we're going to treat it a different way. But if you have a node, if the node they're trying to insert before it actually is not the first node, then that's going to be a different story. So in this case, I'm inserting 3 before node 1. Okay, let me just go and take that out. I don't know why I'm using the mouse where I have the tablet. So I'm trying to insert a node before node 1. Now, since node 1 is the first node, what's going to happen? The new node is going to be created, which is n3, which is 30. And then I'm going to have n here. And then the head, instead of pointing to... Before we do that, what I'm going to do, I'm going to make node 3 next to be pointing here. And I'm going to get the head to be pointing here. And that's what's going on here. How is that possible? I'm going to show you in a sec. But remember here, there is a good reason why we're using this ampersand here. Now, let's look at this example here. I'm trying to insert a new node, which is n40. So let's go ahead and create n40. This is 40, and this is n. And remember, n at the beginning pointing nothing. And I'm trying to insert it before node 2. So this is node 2. I'm trying to insert it before. So it's supposed to be in this area here. Okay, so what am I going to do? This is very, very important to understand. I'm going to start from the head, and I'm going to go through all the nodes that I have until I reach to this node. This next, that's the next that I'm looking for. This next here that I have, I'm going to be searching for this node, this next. The moment I find this next, I'm going to say, from this next, go to the next node and check the data. Okay, for that node, which basically, again, this is the target node that I'm passing. If it happened that this node is this n here, this next is pointing to a node that has a value of 20, which happened the same as the value of node 20, that basically means I got to the node that I'm looking for. So I'm going to be searching in a sequence format for the n that's pointing to a node which have a data type equal to whatever node 2 is. The moment you find this N2, you're just going to have to insert after this node, just like we did before. First thing we're going to do, we're going to make this node point to this node. And then after that, we're going to make this node here to point to this node. And here we go. I inserted 10, 20, and then I inserted 30 before 10, and then I inserted 40 before 20, and this is the order. It's going to go 30, 10, 40, and 20. Now again, I didn't talk about the method add before, and I'm going to show you how does it work in a sec. Let me just run the project. So you'll see that the results is 30, 10, 40, and 20. Okay, now with that being said, let's go ahead and try to understand how does this method works. Now, the first thing I'm going to do, I'm going to make a mistake, okay, just to show you what's going to happen. Let me take this away, take this away, take this away, okay? And of course, I have to come here and take this away and take this away. So those add before, remember here, this is a function. It doesn't belong to the class. The reason why it doesn't belong to the class because I am scanning the whole list of nodes. So it's not a node, a single node. And remember, this class is just about one node. So I needed to create an actually function that will give me access and make me able to scan the whole nodes. Remember, all the methods inside this class belong to a single node. Whatever I'm doing here should be applied to the whole list, and that's why I have it as a function. So let's look here. I'm passing, every time I call add before, I'm passing the head because that's my starting point. This is my target node. I'm looking for that node so I can find the node before it, and this is my node that I'm trying to insert. So let's look here. I'm passing the head, this is the target node, and this is the new node. The first thing I'm going to do here, I'm going to check if the head actually equals the target node. What does that mean? That basically means I'm checking if the node that I'm trying to insert, the target node that I'm looking for, is actually the first node. If that's the case, a very simple thing. New node, set the next node to be the target node, which is the first one, and then after that, change the head to be the new node. That's how simple it is. Now, if that's not the case, what I'm going to do, this here, you see this part is me repeating. It's not repeating, actually. This is what I'm doing here. At the beginning, I'm going to create a temp, and I'm going to set it to head, and look at this. Temp get next. So you go to the next element of node. If it doesn't point to null pointer, if it doesn't equal the null pointer, this is my while loop, okay? So I'm going to do this. This while loop is going to end by the time I get to the end of the loop, okay, if I get to the end of that list. Anyway, but again, this is, again, very, very important. As long as the next node doesn't equal null pointer, we're going to do this. We're going to check. Look at this. Temp get next, so go to the next node and read the data of the next node. If that data that you read from the next node equal to the target node data, if that's the case, that basically means we found the node before this node, the target node. And all I'm going to do, look at this part here. This is very, very similar to this part. I'm adding the node after the temp. And then after that, very, very important, you have to break. Once you inserted the node, there's no more reason for you to continue the process and you leave. But if that's not the case, here, the next node, you get the data, it doesn't equal the target. You're just going to have to update the temp to move to the next node. And you're going to keep going, keep going, keep going until you find a match and you break, or until you get to the end. And if you got to the end, basically, whatever you're trying to insert actually is not part of that linked list. Now, I told you that this is not going to work. And let me show you why it's not going to work by applying this simple debugging. Now, what I wanted you to do here, I want you to pay attention to something very, very important. I'm going to run it first. And here it is. Now, oops, why is that the main function? I didn't call this part. Oh, I made a mistake. Let me just close it. Let me start fresh. This is supposed to be here. Run it again. And here we go. So I am at this point. Now, before I get to the add before, let's go back here and look. I inserted node 1. I inserted node 2. And now I'm calling for this function. Let's look at this point here for the variables. This is my head. Look at the head. The x of the head equal 10, which is okay. The next of the head equal 20. You see, this is my first node with 10, And this is my next of it, which is basically pointing to the node with 20, and 20 next is actually null. It doesn't point to anything. That's clear. Okay, now let's keep going. In this function here, I decided that I'm going to insert node 3 before node 1, so that's the new head. Look what's going to happen here. This is extremely important. So this condition is going to be true. I'm going to apply the changes. Everything is cool. Let me show you what's going to happen here. Look at this head now. Head now equals 30. The next of the 30 is 10. And the next of the 10 is 20. So everything looks cool. Everything looks fine. Look what's going to happen after I leave this function. I'm done. I am back. Look what happened to node. Sorry, to the head. It went back to 10, 20. So the change that I applied here wasn't applied at all. Okay? There's a reason for that, of course. So how do I keep the change that I applied when I go back to the function, to the main function? The idea here is you need to pass the address of, where is it? Of the head. Not only the head. I know the head by itself, it's a pointer, but you're creating another copy of that pointer, and basically they're pointing to two different, you're not going to keep, mainly you're not going to be able to keep the changes that you applied. So here's what we need to do. We need to take the address of the pointer. So when you take an address of a pointer, you will end up having a pointer to a pointer. And that's why I had to come here and put a double asterisk. This is why I'm not a very big fan of double pointers, because it's a little bit complicated to understand. So I have to dereference every single pointer that I had here for me to be able to keep the change that I am applying here. Notice here, I'm not doing this for the target node and the new node. There's no need. They can change as much as they want, but we need to keep the change in the head. That's the most important part when we move between those functions. Now let me just run it again. Let me take this away, and you will notice that this actually will fix the problem. Let me just put the... let me put it here. And let me just show you what's going to happen now. So you can see here, if you go here and look, I do have 10 and I have 20, so everything looks okay. This is going to be true, this is going to be true, and then it's going to be executed, and now I'm back. Look what I'm back. What happened here? It's still 30, still 10, still 20. So no change was applied. Sorry, the change was actually kept. Let's go ahead to the last node that I'm going to add. Calling the function again. This condition is going to be false this time. It's going to go to the else, and now I'm going to have a while loop. So the first one is 30. No match. Go to the next one. The next one is 10. No match. Oh, actually, no. Where is it? Where am I right now? Yep, actually, 30, 10. Yeah, okay, if it was matched. So here we go. Change, 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 and now we're back. Let's look at the head again. I got 30. I got 10, I got 40, and then I got 20. You can see here now the order is correct. Now if I stop, let me take those points away. Let me run it, and you can see 30, 10, 40, and 20. Okay, so I hope, again, I know it's not that easy, but I hope it makes it a little bit easy to understand how do you deal with pointers and how do you deal with linked lists. Now, in reality, let me just tell you, for the standard template library, we do have a class called node, and we do have another class called list, and then the node is basically going to use nodes as in a composition. So basically, the class list will contain nodes, and then you're going to have to add all these adding and removing functions or methods to that list class. There's some sort of inheritance, composition, so details of object-oriented programming that I didn't want to go through in this video, so I try to make it as simple as possible. The only complicated part, I believe, is the fact that I have to go with double pointer, so it's a pointer to a pointer to be able to handle this situation. I hope this thing cleared the concept a little bit for you, and I'll see you guys later in a new video.